For this question, the one I'm talking about here is number 11. The dragster and driver together have a mass of 915 kilograms. We're going to read it over and then I'll show you how this one plays out. It's a three-part question. So part one here, and then the next part is on this page here. So let's just look it over together. A dragster and driver together have a mass of 915 kilograms. The dragster, starting from rest, so that's always important, starting from rest, attains a speed of 26.4 meters per second in 0.62 seconds. Find the average acceleration of the dragster during this time interval. So I have an initial velocity, a final velocity, and a time, so I can find my acceleration from that, and the mass is going to play in a little bit later. So let me minimize this and get rid of these things. Okay, so here, let's set this up. Alright, so from my information there, I know that my initial velocity is 0. My final velocity is going to be 26.4 meters per second, and the amount of time that took was 0.62 seconds. Okay, now you'll notice I'm in meters per second and my time is in seconds. If this was in kilometers per hour, or if this was in a different unit for time, I'd have to change them so that they would be in the same unit there. Now I know my acceleration equation is my change in velocity divided by my change in time. So there, that will be 26.4 meters per second minus 0 meters per second, which I don't really need to even write down, divided by 0.62 seconds. And when you work that out, so you do that in your calculator, you will get 42.58 meters per second squared. Okay. So that's my first section here. Now if I go back to this here, not that one, right here. So let's see, this is number 11. If I put that in here, let's see, 42.58, and submit that. Nice. Okay, so the next question, it says, what is the size of the average force of the dragster during this time interval? So for force, we need a different equation. I know that my force is always equal to my mass times my acceleration. So I have my acceleration. My mass was given at the start of the question, and the total mass of the dragster and driver, and they're moving together as a unit, was 915.4 kilograms. Okay, now whenever you're dealing with mass, you always want it to be in kilograms. So I know my mass, I know my acceleration. I can put these together here. 915.4 kilograms times my acceleration of 42.58 meters per second squared. So looking at the force here, when I calculate these two things out, my force here is going to be 38,978.3 newtons. So that's a lot of force. And now those dragsters are pretty big, so that also kind of makes sense there. So here, if I put that answer in to here, let's see, this was number 12. That was 38,978.3 newtons. And I will submit that. Nice. Okay, and for the last one here, it says it's wondering if you have the mass of the driver, what is the force of the driver from the car going to be? Now you kind of have to read over this. Assume that the driver has a mass of 74.8 kilograms. What horizontal force does the seat exert on the driver? So for this one, Let me get a different color here. I'm still going to use my F equals ma equation, but for this one, the acceleration is the same because the driver and the car are accelerating at the same rate, but this time the mass is only going to be of the driver. So here, 75.2. Let me just double check that number. Let's see, 74.8, sorry, so I should change that here. 74.8. 74.8 kilograms times my acceleration, which was 42.58 meters per second squared. I'll just get out my calculator here and give that a try on the side. So 74.8 times 42.58, I'm going to get, oops, I'll have to try that one more time. I get 3,184, so my force is going to be 3,184 newtons, or if I would round, it would be 3,185. And newtons there. So 3,185. I'll go and try and put that in here. 3,185 newtons. And again, I got that one there. So that's how you go about that question.